Alright, for this video we'll be doing a small explanation of the electronics. I'll be going through the wire diagram here and we'll be showing the different parts here on our little demonstration system. Now since we'll be working with electronics today, safety first. We always wear safety goggles and we have our measuring tool with us right here. First thing, this is our design, or at least the old version of the design. Some of the things in this plan have changed as we've adapted our design to meet our project requirements. First step is power. Our power source is the ME gondola on the balloon. It'll supply us with 27.7 volts. We run everything within our system on 12 volts, therefore we need a DC to DC converter. We've chosen the pulse dimension, CD5.121. It's pretty reliable. It has an input of 24 volts, but a tolerance of plus minus 30%, which is pretty high. It's actually a good little tool. And its output is 8 amps. So in all of our systems together have to be less than 7 amps. So we have a 12.5% safety tolerance. Everything will come into the terminal blocks here. These are bridge terminal blocks so that all 8 inputs here are on the same potential. This is plus and this is minus. These will then power our pumps and our valves. Let's go to the next step. This is our microcontroller. For the project itself, we'll be using an Arduino Mega. For our demonstration system, we have an Arduino Uno. We'll be putting an Ethernet shield onto it so that we'll be able to communicate over TCP/IP. We'll have 3 internet ports. One port will be for command systems. The second port will be for temperature collection. The third port will be for altitude measurement collection. The inputs and outputs are here as follows. And the Arduino also powers our measurement equipment. It comes out of the 5 volts here. And then we'll go to these terminals. This is our temperature testing. We have our plus volts, ground, and our data cable for our analog system. We will be triggering our pumps over relays. We have these relays here from Fender. They're digital relays. They take a 5 volt signal and can power up to 24 volts. So that's where our 12 volt pumps and 12 volt valves will be triggered. And here they are in the wire diagram.
Can you show them?
Here. These are the different ones. I think in the wire diagram at the moment we have 10, right? Our new design will have 4 valves and 5 pumps. Will only need 9 relays instead of 10.
Well, the relays here.
Yeah, these are the relays here. We have them attached to normally open so that the circuit will be open during flight and we will trigger them to turn them off. Actually, turn them on, excuse me, and close the circuit. Now, very important for our system is to get inputs to prove whether or not the pumps and valves are actually on. And for that reason, we had to attach an optocoupler. We're using the Alzard optocoupler from China. And what it does is it takes 12 volts and turns it into 5 volts. The reason being, our pumps and valves operate on 12 volts, and the Arduino can only take in 5 volt inputs. Therefore, we need to trigger a system that will provide us with a 5 volt input. We have it currently attached to normally closed, so that it will always, because in China, the closed position tends to be 0 volts. So it means that it's true, that the signal true comes at 0 volts. So we decided to place it on normally closed so that we'll be getting a 0 volt signal when the pump is off. When it switches, we'll be getting our 5 volt signal, our input that the pump is on. Here we have our two sensors. We have the MS5607 altimeter from Teralax. It's been used on several experiments in the past and has been proven to operate up to 60,000 meters or 60 kilometers. We have our temperatures as sensors, a DS18B20, which looks similar to this, although this is an LM35. The DS18B20 can go to minus 100 degrees Celsius, which is better for us. And then here are our cryo valves. They are 12 volt, 15 watt valves. When we run the full system, this will actually be removed. We decided to remove the chamber. When the system is running fully, we'll have 2.5 amps coming from the valves themselves, and the pumps will be about 3.5 amps. So we'll be looking at about 6 amps for the, or less than 6 amps, sorry. Less than 6 amps for the total consumption during collection, which will be about 2 hours in duration. And then here's simply our motor connections. We are using these diaphragm pumps. They actually aren't 6 watts. They're a little bit lower because I ended up finding a better pump from the same company. They're usually more on the order of about 5 watts or so. Yeah, and they're diaphragm pumps which are used in the medical industry, therefore they're clean. It's got a clean flow. The other good part about a diaphragm pump is if the pump fails, it'll stay sealed, which is very important for us. Otherwise we lose flow rate. And that is the small introduction into our electrical diagram.